everything is pretty much the same as what we did last week. So we had a fire drill last period, as y'all know, and I was chatting with some of my first period kids outside, and they're like, this is really easy. It's just like Friday and plugging in and stuff like that. So it's really about calculator work today, being able to put things in our calculator and round correctly and that kind of thing. Okay, nothing difficult at all. So pretty short notes and pretty short homework. I think you guys might be able to finish it in class. Okay, so let us get started. We're finishing 2.5 day 2, like I said, today, and then 2.6 is supposed to be 2 days. I have been wrestling with that section. If you remember, there was a section in Unit 1, I think it was like 1.3 or 1.6, I can't remember, but it was like, I said I hated the way it was done, so I made my own notes and gave them to you. That's what we're going to do tomorrow. We're not going to use the 2.6 notes that I gave you. Don't get rid of them yet. Let me just make sure. But you might be able to get rid of a whole bunch of pieces of paper in there because it's really long. It's 2 days. And we can do it in 1 day with what we need to know. So I will hand you notes to put in your notebooks tomorrow. I'll have them hole punched and everything for you. And then Wednesday's a work day. So just kind of getting caught up, okay? And a homework chapter on Wednesday. All right. So we, on Friday, learned a lot like half-lives and doubling lives and plugging numbers in and knowing which one's your initial amount, all that stuff. Practice putting it in the calculator, pretty simple. One problem that we did was a little more involved, if you remember. And I said at the time, let me just pull it up. It was this. Remember, without a calculator given 2 points, you had to like plug in. Remember this? And then you had one of them to do in your homework. Luke, this is really the only thing you would want to make sure you know how to do from Fridays. Everything else you'll be fine, especially with today's. But we have to know how to do it by hand. And so in the notes in number 12, okay, so make sure you know how to do number 12 in the homework. Wednesday would be a great day to ask me for help on it if you are struggling with those, okay? And then I promised you that today I would show you how to do it in seconds in your calculator. And so that's what our first example is. What you see at the top of the paper is the directions for how to do it. And we've already done this before, so you don't need to really study this or anything. This was printed in your notes last unit when we did, I think it was last unit. And then I actually made a pink sheet of it for you because I said this is so important for you to know. So you also have a pink sheet with this already written on it, okay? There is one change on it. We don't use that if you want to change it now, in case you do want to look at this. I think when you do this problem with me in a second, you're going to remember all these steps. I mean, it looks pretty complicated, right, just at first glance. But I think once we get going with it, you're going to remember, right? Okay, so it says to use a graphing calculator to find the exponential equation that contains these 2 points. And then we're going to sketch it and answer some questions about it, okay? Just like on Friday, we were given 2 points, and we had to do it without a calculator. So I would go ahead and clear your RAM, please. And let me remind you how to do this. So if you were given an equation, like y equals something, we know where to go there at the y equals, and we could type it in, right? But what do we do when we have 2 points? Understand 2 points, and you don't have to write this. 2 points are like an XY chart, right? Just written as 2 separate points. Okay, so the 2 x values, the 2 y values. So we are going to go to Stat and then Enter, where it says Edit. So we're already on it. You hit Enter. And remember, List 1 is your x values, and List 2 is your y values. It's just a really short list, right? It's just 2 points. Doesn't matter. That's all we need. There's 3 and 7. 18.2, 94.7. Enter. Right? Our 2 ordered pairs. Then we go to Stat. Again, that's where we just started. Over to Calc. And we've used linear regression, quadratic regression, cubic regression. I don't know if we used quartic, but exponential regression is where we are, and that is number 0. So you can either scroll to it and hit Enter, or when you get to this, you can just when I'm in this menu, if I just hit 0, it goes right to exponential regression. So all of our calculators have that at 0. Right? So this is where the directions changed. If you remember, you want to store your regression equation, okay? Whatever they're about to give us as our equation for it, we want to store it in the brain of the calculator so we can answer some other questions about it. If it was just write the equation, then you don't really have to store it, but we are going to answer some questions about it, so we want to store it. And that's when you use your alpha trace enter. And it's just telling us it's going to put it in y equals 1, y sub 1 for us. Keep on going to calculate and then hit enter. And it'll give you your A and your B value. Let's round to 3 decimal places. Remember, if the third number is a 0, it's optional. That's a lot faster than what we did on Friday. A lot faster. Okay? Now it says to sketch the grid at the right. Oh, but look at what part C is. Label the y-intercept. I see that coming. I should be able to tell what my y-intercept is just by knowing the parts of an exponential function. Remember, that's my A, that's my B. A is my initial value, like in a word problem, or my y-intercept on a graph. So I'm just going to make sure I hit the y-axis somewhere down here. And then it's growing, right? It's greater than 1, so it makes sense. It's making like the J. And my y-intercept would be at 0, 5.283. So there's those 2 parts. Okay, it's a sketch. It doesn't have to be perfect. And then it says find the value of x when y is 50. What is x when y is 50? So think about what it's asking. It wants the x value when y is 50. So let's look at our table and see what's going on in our table. So I want y is 50. Not looking like my table is going to help me. I could narrow it down. It's going to be between 5 and 6. So it's going to be 5 point something, right? Because it's between 41 and 62. So somewhere in there. So it's kind of good to just know that to make sure my answer makes sense when I do this. Does anybody remember what that part on our calculator is that we're going to use to figure out what x is when y is 50? No? Not table set. Those are table set and zoom and window are ways to change what we look at, okay? But we want to know a very specific x value given a y value. We just did it last week a bunch of times. What we're asking ourselves is when y is 50, what is that x value? So what is that x value when y is 50? What's that called? Intersection, right? That is the intersection. So remember, it's a clever way. I like using that word because I feel like it's very clever. It's a little sneaky. It doesn't tell us to graph a horizontal line at 50, but we can do that very easily, right on the same graph. I go to y sub 2 and type in 50, hit graph, and see what I have. Now remember, your calculator window defaults to 10 in every direction. We already know that our y-intercept is at 50, and we're only, if you go to window, we're only at 10. So you know you're going to have to go above that. You could change some of the other ones if you want to. I'm picking 70, 60 would be fine. I wouldn't pick 50, okay? Understand why I wouldn't pick 50 is because when you graph that, I'm not going to be able to get on either side of it. 50, if I'm only going up to y equals 50, it's going to be at the very top. You can kind of see it filled in there. How do I get on either side of it? It could be a little tricky for my intersection step. So that's why I would go above 50, 60 I did last period. I'm picking 70 now. But the point is, if you're going to find an intersection, a min, a max, a 0, you have to be able to see where that happens on your graph. So now I can clearly see where my intersection is. So I go to calc, which is above trace. So second calc, we want number 5, which is our intersection. And if you look, I have a cursor blinking right here. I could hit enter right now. Remember, you don't have to be like right up against it. You can go closer if you want, but anywhere before we get to the intersection is where you can hit enter. Okay, so it doesn't have to be right against it, up against it. So enter, and see how it kind of like stamped that cursor right there. I picked that. Now it gave me a new cursor. I'm going to arrow over. I want to get to the other side of my intersection. Okay, and then I hit anywhere over there. Okay, could be right next to it, could be further down the road. Hit enter, and we want it to guess what that intersection is between these 2 points. And it will give us, like we thought, 5 point something, between 5 and 6. So our x value is approximately 5.451. The answer makes sense. Okay. Any questions on that? Okay. We talked, I think on Friday, maybe Thursday, I don't know, what E means. E is used in a lot of exponential functions. It's an irrational number, meaning it can't be written as a fraction, that goes on forever. And so it represents this number. There's 2 places to use it on your calculator screen. One place is above the division symbol. It's blue, so I would hit second divide. And you can see it puts that little tiny E on there. And if you hit enter, you'll see that same number that's there. So E is a variable, technically, right, the letter, but it means a very specific number. It's never going to change. It's always that number. But because it's irrational and it's commonly used all the time, we have somebody made up this letter that represents it, okay? Just like pi is another value we use all the time. We use that symbol for pi, but we know it equals that, okay? So they're very similar. They're variables or symbols that represent a specific number, okay? So that's one place you can see the E. Another place is above the natural log button, this ln, right above it. It says e to the x. We're going to be using that one because we're going to be putting powers in. Could I use this one and then put a power? The answer is yes. But I have a quick button for that. Okay, so when we get to our next problem, that's what I'll be talking about, which is example 8. All right, let me read the sciencey question. Lots of science in this class, especially second semester. Those of you that are in physics, when you get to trig, there's a ton of physicsy questions. The atmospheric pressure P on a commercial airline decreases as the plane height increases. The pressure is measured in millimeters of mercury, so that's like the little mmHg, and is related to the height h in kilometers above sea level. The relationship can be modeled by this function. They're giving us a function. So P of h, that's the pressure at h height. H is the height above sea level. Okay, so it's good to know what the letters mean. You know? So the question is, what is the atmospheric pressure at a height of 4.5? Okay, there's only one true variable in this word problem, in this equation. It's h. Remember, E is an actual value. So we're just going to plug in h is 4.5. Okay, so I'm just going to do it right in my calculator. 760. And then, again, second ln gives you the e and the exponent all in one button. Negative 0.145 h, which means times, what's the height? 4.5. And hit enter. So just really being able to put it in your calculator correctly and then round to 3 decimal places. So the height would be approximately 395.764 of those mmHgs. So find the pressure when the airline reaches a height of 10 kilometers. So just something, like, I like to kind of keep in the back of my mind, it said the pressure decreases as the plane's height increases. So, you know, if this was a high-stakes test, like a unit test or the AP exam or whatever, I'd kind of might bookmark that thought in my mind and say, okay, I'm going to a higher height, right? Height was 4.5, now it's 10. My number should be less than what I just got. Because it said the mmHgs decrease as we go higher, okay? So just something to think about So I'm just going to change in my equation the height. Negative 0.145 times 10. And I did get a smaller number, which is what I should have had. Okay? Okay, so just like Friday, lots of different word problems, equations given to us, and we just had to usually plug numbers into it and simplify it on our calculator. Okay? And we have one more concept to talk about, which you probably will remember from Algebra 2, and that's compounding formulas. Let's read on the next page, down here. Last bit of notes here. Compound, and this is what I like about these formulas is this is real life stuff. This is stuff that you can and probably will encounter in your adult lives. Like this really happens. Okay, like we're like air pressure in a cabin. Okay, whatever. Compound interest is interest computed on an original investment plus an accumulated interest. If an initial sum of money, initial keyword. Keep initial and principal together, is invested at an annual percentage rate, R, in decimal form, compounded once a year. We know the accumulated value, A of T, can be found using this. I don't know that we knew that, but okay, they say we knew that. Who cares? Some banking institutions compound at different time intervals, such as monthly, quarterly, semi-annually, and continuously. After T years, the balance, A of T, in account with principal P and annual interest rate, R, in decimal form, is given by the following formulas. Okay, so there are two formulas, and it has to do with how often we're compounding. So let me explain compounding. Grandma gives you $500 for your birthday, okay? And you're like, I'm doing well. I'm going to put this not in a savings account. I'm going to go to Bank of America and see if they have any better options for me to make money off of my principal. My $500 is a principal. And BOA says, we can offer you this, we can offer you this, we can offer you this. We can offer you 5% interest if you keep the money in there for 10 years, and we'll compound it monthly, and I'll come back to compounding. Or we can compound it continuously if you keep it in for 3 years at this interest rate. And so they might confuse you with all these numbers. But what compounding means is, so for example, if I took that $500 and I compound it monthly, they're going to compound it monthly. That means they take that money, that $5,000, and once a month they find whatever the interest is of whatever your rate is, and they add it to your total. So now let's say you have $550. Then on the next month, they're figuring your interest on $550 instead of $500. So the more often you compound, the quicker your money grows. Think about it if it was like twice a year, semi-annually. So you have $500 in there for 6 months. Then they put some interest on it, $550. Okay. Now you have to wait another 6 months before they put more money on it. So you can see that if they did it monthly, or continuously, which is even more often than daily somehow, the more often it compounds, the better you are off, okay? Now, these two formulas have a lot of similar variables, like P, okay? So P is your investment, and that word can mean so many things. Grandma's money she gave you, your babysitting money, whatever. Your money, what you start with, initial amount, okay? R is your percent, always, but you have to change it to a decimal, just like we have been doing. The good news is we are using true R, not B. So we don't have to add or subtract 1. You don't have to worry about with these. These formulas are built for money only, so it's the 1 is, you can see, especially in this formula, it's built into the formula. And then T is time. So those are the ones they have in common. It's time in years usually. So I think they could change it. The one that's different, of course, is N. N is only in the first. Okay, so if it says compounding continuously, we use what we call the PERT formula. Principal times that button E to the power of R times T. We're going to do one of those in a second. If it says it compounds monthly, quarterly, daily, that's this formula. Okay, so let's just, if you need to write these down, compounds N. So weekly would be 52. There's 52 weeks in a year, right? Monthly would be 12. Semi-annually is twice a year. Semi-annually. Think of semi, like semi-monthly would be twice a month. A very common one is this one. What do you think n equals 4 would be? What? Well, it's quarter. Yeah, quarterly. There's 4 quarters in a year in a football game and some other things that I don't know. Okay, but that's a really common one. I will say this formula, the compounding formula, is tricky to put in your calculator. So when you get to these on your homework, don't just write my answer down because you understand it. You have to practice putting them in the calculator because you can't just go left to right like you want to, right? You have to break the formula down a little bit. And you'll see it in my work, but you need to like experience it by doing, okay? Let's do our last example here. Suppose you win a writer's competition at the start of ninth, I think that's supposed to say grade, and you deposited they deposited $5,000 in an account for you, okay? So you won some contest, won $5,000. They put it in an account which earns you 6.25 annual interest, but then it's compounded continuously. The minute you hear that word, you know it's your PERT formula. How much will be in the account when you enter college 4 years later? So when you hear continuously, you know it's PERT. That's the only time you use that formula, and that's the only word that's ever used. So continuous or continuously is the PERT formula. So breaking it down, principal is what you start with, your initial amount, your investment. That's what you started with. E is a button on your calculator, right? R is 6.25%. Always change it to a decimal. And T is 4 years. Okay? And we just put it in our calculator. Nope. It isn't. 1, 2. Do you see that? Okay. I mean, you can put a 0 in front. You can put 0.0625, but you don't have to. All right, so principal, that E button above natural log, right, and it gives us the exponent times R, 0.0625 times T. That one you can just type right in your calculator left to right. And it doesn't tell you what to round to because it's money. We should know to round to the hundredths place, 2 decimals. So this is how much would be in your account after 4 years. I've also seen a question like where it'll say, well, how much did the student make? Well, you would have to subtract out the 5. Well, I mean, I guess technically the whole amount was given to them, but how much interest was earned, right? You could subtract out the 5,000, and in 4 years, the student earned $1,420 interest, okay, above the 5,000. Okay, so just being able to put that in our calculator. Questions before we go? Don't erase it from your calculator. I'm going to come look at it, okay? Right now. Here is the assignment, and I'm going to do the FRQ with you right now because there isn't one in the directions or anywhere in the notes, so we need to go over it together. So, yeah, you're looking at 0. So don't erase it, just do other things because we have to take things out. Yeah. Okay, so B9, 1 through 9, all, unless I say otherwise. And then we're going to do A, B, C of the FRQ. I'm going to do it with you right now. Okay, so go to the FRQ, my dears. Go to it. All right, so I have mentioned it a couple times, but we haven't really experienced where, okay, so let me tell you what we're doing. XY chart given to us. So we have a bunch of X's and a bunch of Y values, okay? And it's asking for us to state the end behavior, determine the domain and range, and find the horizontal asymptote, okay? Those are the three things that we're going to do just by looking at the table of values without using our calculators. All right, it tells us what form this is in. It's an exponential function. It could have a vertical movement up or down. That's what C would be, up or down. So let's see what we have here. We have a bunch of x values from negatives to positives, right? X values. So you can picture where that is. Sorry. There's someone in front of you, so just wait. She's going to wait till we do this. We're doing a homework problem together. Okay. Okay. One of the things I have said to you guys is that end behavior and horizontal asymptotes have a very strong relationship. We haven't really seen it yet. I've kind of just talked about it. That's why I like this problem. So really, it's kind of a neat problem. Without using a calculator, how can we tell this? So end behavior is as x goes left and x goes right, what is y doing, okay? And so let's set up our limit stuff, okay? The limit of our graph as x approaches negative infinity, okay? That's going to the left. And let's do the limit of the function as x goes to the right, okay? So what's happening in these two directions? Okay, so let's look at what's happening to the left. Look at these y values. Negative 4.5, negative 15, negative 99, negative 387. This is pretty traditional exponential function behavior. It jumps very quickly. These numbers are getting exponentially smaller, and by this behavior, you can predict that it's just going to keep going forever towards what? Negative infinity. That's right. It's just going to keep on going down. The numbers are jumping really big. There's no way to know. There's nothing there telling you that it's going to stop, okay? But now let's compare it to what's happening as we go to the right. So as we go towards the right, we start really slowing down, right? We're at negative 4.5, negative 3.75, still in the negative 3s. This is an example of we are reaching really close to an asymptote of what number? What number are we getting really, really close to? Negative 3, right? These decimals, if we kept going, would just be tinier, but we would still have a negative 3 in front, okay? So that means we are approaching negative 3. Look at the difference on the left side and the right side. So if I sketch this graph, and that's not something it asks you to do, but try and picture it, okay? We have an x-axis and a y-axis. As I go to the left, my numbers are really, really low, small. And then as I go to the right, they're still negative, but they're getting bigger as I go to the right. And as I said, we can't get past this y equals negative 3. We can't get past it. So it would look something like this, right? This is going to keep going down without bound, is what they say. And this is going to the right forever, right? We know that because the domain of these graphs is all real numbers. It keeps going to the right, but it's never going to get across that negative 3. Okay, that's what that looks like. So domain, like I just said, is all real numbers, negative infinity to infinity. And what would the range be? Negative infinity to negative 3. Shannon, can I change the order of that? Can I put negative 3 first? You can if you want to get it wrong. Yeah. No, you can't. Okay? Least to greatest, always. All right, so what's our horizontal asymptote? What is it? I like that you said y equals negative 3. Negative 3 would be marked wrong. Y equals negative 3. All right, you talking about here? Nope, it would still be negative infinity to negative 4. Negative infinity is smaller than anything because it's saying the number is below wherever we are. Okay. All right, so that's it for the FRQ. with the key up pulling you. Start off with what? Nope. That's if you had the equation. When you have 2 points, you use stat enter. List 1, list 2. Remember, the directions are on the front page, too.